Just thought I'd do a quick video on my Lidar 3D object scanner. This is what it looks like. I started off with the open source 3D scanner. Let me show you what that looks like. It uses dual lasers, which are dangerous to the eyes and therefore it's quite hard to demonstrate. It uses trigonometry to work out the distances to the object, and that can be prone to error. Got to get your angles exactly right. And it results in a point cloud that you then turn into an object, and you get reasonable results, but because the camera is stationary, it does lose some detail. The tops of the objects, for instance, you don't get. So I wonder if I could do better with a Lidar unit. This is my Lidar unit here. It's a SLAMTEC Lidar, cost me about £85, so it's quite a cheap little project, and I've used it with a Raspberry Pi. This is a Raspberry Pi 4, and a simple bit of electronics for stepper motors. I used the open source turntable, and then I've built a mount for it there. The Lidar uses a low power laser with pulses, so eye safety isn't a problem. And also it doesn't use, it doesn't have to work angles out in order to get the distance to the object. It gives me the distance directly, which makes it a bit easier. So I bought this and realised quite quickly that I didn't know how to program it, and I couldn't work out how to mount it. And then I found a really good project on the internet by Chris Martin of an area scanner. So I built that, and that's my area scanner there. It rotates around and builds an image of a room up. He used a Beagle board, and I didn't have one of those. I wanted to do it with a Raspberry Pi, so I converted the code to a Raspberry Pi, and in doing so understood how he programmed it. So with that, and also the idea of his base, I built my base here for my Lidar. In order to get over the limitation of the camera being stationary, I was able to put the Lidar on a lead screw here, so it can go up and down and build an image of the object at different levels, and therefore I get detail at the top of the object. I'll show you how it works. This is the scanner in action. I've chosen an owl to scan as it's a fairly simple object but with good bold detail. So this is the web front end that I've written for my scanner with a lot of help from Ian Malcolm. It allows you to set up the scan. This one's doing 5 levels. The Lidar will rotate twice before it moves the turntable onto the next scan. And this is the number of scans per turntable rotation, which is 800, which again isn't particularly fine, but it's just for demonstration. The scanner firmware is read by this, and it does change the code slightly. I had quite a lot of problems with scanner firmware. The different versions have different timings. They measure differently, so that the distance to the turntable changes according to the firmware version, which is a bit odd. This shows you the position of the turntable and where we are in height on the scanner. It's estimating a runtime of 29 minutes. So again, quite a quick scan, and I'll show you the results when it's finished. So So the scan's now finished. The file we want is called demoal.ply. It does it in PLY format, which is a fairly standard format, and we just download the file here. So I'll just download that. Right, so now we need to go into MeshLab and process our file. There's our owl. It's in different colours because every time I move the scanner to a different level, I put it in a different colour, and I did that so I could align the images up nicely. We can get rid of the colour once we've finished. So we need to compute the normals and then put a surface on this. So let's do that. This won't take very long for this scan because it wasn't a very complex scan, but if you had a lot more points in your point cloud, then it can take a while. And now we put a surface on it. I'm putting a fair bit of smoothing on this. Put too much smoothing on and you lose the detail. Too little and it looks a bit rough. So just getting that compromise. I can see that my normals are around the wrong way, so let's just invert those. And there we have our owl. I can get rid of the colouring now. His head's got a bit bobbly, but we can get rid of that. Let's just do that quick. Smooth that off. Now the rest of the detail is probably better being viewed in Blender, so let's just save that and put it into Blender. So there's Blender. Oh yeah, there's a bit more detail there. His base isn't right, so let's just put that right. Something like that, I reckon. Probably about right. And yeah, you can see he's got a mottled tummy, and these are feathers, so they're not going to be smooth. It's looking pretty much like the original. Pretty good.